Hello. In this video, I'm going to discuss section 4.5, Topographic Surveys, from the Bridge Builder Manual, Volume 1. The learning objectives are to understand surveying in the context of an international bridge project, understand the equipment used, become familiar with the forms we need to complete, and understand best practices for choosing points and gathering data throughout the surveying process. If you've ever participated in a bridge project, you already know how essential it is to have a topographic survey of the site profile. How else will we know that proper freeboard is met? Setbacks from the edge of bank exceed 3 meters and more. It is also essential that our survey appropriately defines our site. Generally, you've taken the survey at face value, but what if it was wrong? We go through multiple reviews internally to ensure this isn't the case, but it would be a catastrophe if otherwise. A final note to remember is regarding the permanence of a survey profile. In country, it can sometimes take over 16 hours to get to site. And this is actually quite common in Bolivia. Because of this, a survey may have been taken 1 to 2 years before the next site visit for bridge construction to begin. And because of this, it is important that benchmarks are as permanent as possible, such as driven rebar, massive rocks, or trees. We need to be able to find these points upon returning to begin construction. However, sometimes they are moved, or a cornfield is planted in the way, such as the Atiki site I worked on in 2021. And in that case, a meticulous resurvey is required to match up the profile used for the design with the actual site conditions. Now, the manual discusses both products from a survey and the equipment for a topographic survey. The end products are as follows: proposed centerline and profile of plan sketches, 2 permanent benchmarks at least, and that's if you only have to move the instrument once, GPS coordinates, survey data, and site media. These you may be familiar with as what you receive in the NEAT site information folder. However, to get to this point, we need the following equipment. You'll need the survey form, a theodolite or auto level, tripod, plumb bob, which hangs from the auto level to make sure it's level and get your distance to the ground, level rod, measuring tape, both 5 meter and 100 meter, 100 meter to confirm distances, and the 5 meter to generally measure distances in and out of plane or obstructions, batteries and camera, pen and a clipboard, calculator, and a rangefinder or GPS instrument, and then stakes, nails, hammers, spray paint in order to mark your benchmark points. In the following modules, we'll go into detail how to actually use this equipment. But when we begin actually laying out our survey area, figure 4.4 from the manual shows the proper extents. We want at least 35 meters beyond the proposed tower with a 5 meter buffer in either direction to capture any obstructions or obstacles, as well as define enough space to build the abutments. As mentioned before, we want to make sure benchmarks are permanent features, such as large rocks, tree trunks, or rebar. They will serve as a datum point for horizontal and vertical measurements, and anytime we need to move the auto level. When defining key components of the survey within its extents, we usually start with the whole reason we need a bridge, the high water line. This is always set to be 100 meters, and the survey is provided to students by EIA. Our global GPS coordinates aren't as important. What we're more concerned with is relative distances. The high water line is usually sourced from asking community elders in combination with asking about specific storm events. You can take note of erosion, vegetation, and trash deposits to help confirm or deny any suspicions. And it's also good not to suggest a specific high water line. For example, saying, "Is this the high water line?" You want to keep it more open-ended for the risk that people just agree with you. After defining the high water line, A plan and profile sketch are important to have. It's a good visual sanity check once you process the data. The profile should include all survey points, instrument locations and benchmarks, the high water line, and the plan should also include these points and benchmarks, as well as any obstructions, roads, nearby towns, directions, and the stream flow direction. Now for the process of actually selecting survey points. This is usually driven by contour. For example, in a very steep slope, the instrument may need to be moved several times if the measurement can no longer be read. Or in a very long shot on a windy day, it may be impossible to get an accurate reading. And I'll try to draw an annotation for you here. For example, if you have a very steep slope and you're on your, say, left-hand side and your first instrument placement is here, but the level rod only extends to here. That's out of your sight. And therefore, you'd probably need to move the instrument somewhere down here as an intermediate point before you come back up onto the right-hand side to be able to get the details of this area of the survey. It's also mandatory to get the high water line, bottom and top of the riverbank, and tower locations. However, more points should be found and meticulously labeled as to why they were accounted for. Remember, it can be up to 2 years before some of these surveys are revisited. And when there's a significant transverse slope, that means a slope out of the plane of the profile, more guidance is provided in the manual. And those are figures 4.6 and 4.7. This topic is not covered extensively in this course because usually we'll avoid these situations. But if it is necessary, that is the procedure is detailed in the manual. And finally, before leaving the site, it's important that the original data is kept along with its descriptions, and a quick viability check is made. This is done by checking the middle to lower and upper to middle shots for any significant variation. And we'll go through an exercise with this in the next module. Now, the final section of this lecture I'll discuss is the survey media and quality assurance procedure. The manual recommends some standards for survey media, which are to provide visual representation along the center line with descriptive names for all points. Each photo should correspond to a survey stake or label, and each video should be a 360-degree video with commentary in under 30 seconds. Finally, it's important that field staff remember to keep the auto level properly calibrated, or none of this would be correct. Remember that small errors can have massive repercussions when surveying long distances.